This lesson is about graphing inequalities. By now you should be pretty good at graphing equalities. Here we're graphing inequalities which show relationships between two variables where one variable is less than another or an expression involving the other variable. So we'll see what those look like in a minute. Just a reminder of the inequality signs, what greater than or equal to, less than and less than or equal to look like. Easy way to remember is the one that looks like an L is less than. You might remember a little crocodile from junior school or middle school. It eats the biggest number. So I want you to put the correct numbers between these ones, press pause, and then I'll put the solutions up. So 6 is less than 8, so one that looks like an L. 7 is greater than 0, 0 is less than 3. With the negative ones, need to be a little bit careful. -4 is actually greater than -8. And -15 is less than -14. Okay, so just remember those directions. If I want to graph an inequality, all of these graphs are inequalities. I'll first graph it as though it was just an equality, and then I'll decide which direction I'm going to shade in. Okay, a bit of a coloring in exercise. Okay, to distinguish between less than or equal to and less than, a dotted line is used in the less than cases. All right, that'll make more sense soon. So before I can think about graphing and coloring in, I just need to be able to graph the one where it's equals to. I'm going to graph it using a series of points. And I'll substitute in 0 into where x is. That'll give me 1. Okay, then I'll substitute 1 in here. 2 times 1 plus 1 gives me 3. 2 times 2 plus 1 is 5. 2 times 3 plus 1 is 7. So I've got a series of points. I'll just roughly draw what this looks like. 1, 2... With my series of points, it's going to look something like this. That is what my equality would look like. The y equals 2x plus 1. These other 4 options are going to look exactly the same as that line, but perhaps a dotted line and some shading. So I know that they're all essentially going to be passing through this same point. I'm not going to redraw all the detail, okay, because we're just getting an indication of what these look like. So if I want the y values that are greater than 2x plus 1, this line is 2x plus 1. So because this is a greater than equation, I'm going to use a dotted line, okay, passing through where y equals 2x plus 1 was, but then I'm going to shade everything above this. So the dotted line means that I'm not including that line, and this yellow section that I've shaded is indicating that all of these points, every point in here satisfies this inequality that the y coordinate is greater than 2x plus 1. And you could go ahead and test some of these points. In a similar way, if I want to graph y is greater than or equal to 2x plus 1, it'll be the same line, but in this case it'll be a solid line because I'm including all those points on the line. And then I'll get my coloring in pencil and I'll shade everything above that line, everything that's greater than that line. So that's what a greater than graph looks like, shading above the line. Okay, we then move on to the less than and less than or equal to. Okay, I'm graphing a less than relationship, so I'm going to use a dotted line to show that I need it to be less than the 2x plus 1, not including that value. And then I'll get my highlighter out and shade everything that's less than that, everything that's below that line. Finally, we have the less than or equal to, which means I'm including the line, so I'll draw it as a solid line, and I'll shade everything underneath it as well. Just like when I'm writing equations and graphing equations, I need to make sure that I label all of these. So on my graph, I need to show that I'm actually writing the inequality next to each of these graphs. They're shaded regions, many solutions, and we'll now look at a real life scenario where we would use one of these inequality graphs. Okay, in a bit of a scenario, we've got a school organising a trip to the local pool. They can spend a maximum of $200 on the trip. This isn't saying that they're necessarily going to spend the whole $200, just that the maximum they can spend is $200. Adult admission costs $10, whereas student admission costs $5. Choose appropriate variables and represent this relationship with an inequality. Okay. So I don't have these signposts here like I normally do, but I'm going to need to find the variables. I'm going to need to list some parameters. Okay, and then I'm going to try and find the relationship. Okay, but we can wait till we get there. The two variables, what are the two things that are going to be changing? Well, the number of adults and the number of students that can go are the two variables. So I'll let S be the number of students, and I'll let A be the number of adults. In terms of parameters, I know that adult admission costs $10, student costs $5, and are there any other parameters? They can spend a maximum of $200. So the total cost, I'm not going to write equals 200. The total cost needs to be less than or equal to 200. So from here, I can try and write the relationship. I know that the total cost needs to be less than or equal to 200. The total cost, I'll also have another way of writing this. The total cost of S students and A adults will be 10A plus 5S. Okay, similar to all those previous examples we've done, you need to find the total cost of A adults and S students. It's $10 per adult, 10A, and $5 per student, 5S. I know that this total cost also needs to be less than 200. So I can combine these two pieces of information together. So this total cost, 10A plus 5S, needs to be less than or equal to 200. This is my relationship. Okay, I have a graph here waiting for me to graph, so I want to see what this looks like graphically. I'm going to need to find the A-axis intercept and the S-axis intercept. Okay, because I want to use intercepts method to graph this. I know the axis intercept occurs when S equals 0. So I'll go ahead and substitute S equals 0 in here. Remember, just like when we were graphing these ones, I need to substitute S equals 0 in as though I'm reading this as an equal sign. Okay, that's the way I'll be able to find my intercepts. 10A equals 200, A equals 20. I haven't decided which way I'm going to put my variables. I may as well put students on the horizontal axis and adults on the vertical axis. So my axis intercept will be, in terms of SA, it'll be 0, 20. I'll do a similar thing now with the S-axis intercept. I've done the same thing for the S-axis intercept, so I've got my two axis intercepts. Then I'll go to my graph and plot the two intercepts on here, an S-axis and an A-axis. Okay, mark them on, give reasonable amounts of room everywhere, and look at this relationship. I note that it's a less than or equals to relationship, so I can draw the solid line between these 2 points. Okay, with arrows on the end. And then because it's less than or equals to, I'm going to be shading everything below it. So coloring in this big section. So there's my graph colored in. Need to remember that I need to write the inequality beside it. And the shaded region is showing all the possible combinations of students and adults that could go on the trip. This point is 0 students, 20 adults. This point, 40 students, 0 adults. That's probably your favorite scenario. And there's a whole heap of points in between, for example, 10 students and 7 adults, which are possible. You might be thinking, and it's good if you're thinking this, what about all these points down the bottom where we've got negative numbers of adults and students? Well, we'll need more inequalities to get rid of this part. That's pretty much it for this lesson, being able to draw these inequalities. There's a few questions for you to practice down here. This thing that we've constructed here, we're going to call next lesson a constraint. And we're going to have multiple constraints intersecting, but for the moment all you need to do is practice graphing your inequalities so that you're good to go when we start putting them in formal constraints. All right, good luck.